Okay, in the digital computers, we have a technique to check the error. That is related to the parity and error correction. Now we will look at the detail to do the error correction. I suppose the digital signal descends from the transmitter to the receivers and pass to the cables or wireless. When in the cable is made from the copper cables, the copper cable sometimes have effects from the magnetic field and interference that is generate noise when you transmit the data. Not only occur in the cable in metals, but if you do the cable in optical, it's not generate about the noise, but it's a loss about the dropping in the light intensive. So in the wireless, have an effect from the magnetic fields and about the electrical power in high powers generates more magnetic fields to interference and makes a noise. Example, the transmitter send the data here to the receiver. When the signal hit by the noise signal in the red line, some noise signal is very small. It not make a difference or changing the value. Some noise is over. This is noise over high from here and low from this below. It may be generate error. For error here is generate sometimes error in computer to do stopping or hang or stop the terminate the program. Now the first technique to check the error. The first technique we will know about the parity check. The parity is the bit append to the binary sequence in order to add the sum of the number in form even or odd form. Example here, I count at the signal in the bit 1 So here in this 0 1 0 0 it have only one. This is a odd form. This is a odd. I change it to the even form by add 1 at the subtraction here. Add 1 in the subtraction here. This will be 0 1 0 0 1. And not add, this is we call appending. And here 0 1 0 0, this is a odd, and I change it to odd, and I append 0 here. For this, I suppose I have the data 0 1 1 0, and I change it to even. This is so even by 2 1 here. So in the even form is 0 1 1 0 append with 0, and 0 1 1 0 in the input and change it to the odd form, so I append 1. The next one, this is the activity 2.6. Please convert from the input value to the even and odd. Okay, and in this is a 1 0 1 1 0 1 and 1 2 3 4. 4 is a even convert to even, so this is a append with 0. Now your turn to answer this and this. Okay, I think you know about the parities and maybe you confused. The parity append bit to the patterns. Maybe it's lysis, maybe it's generate the overhead when you sending the data from transmitter to a receiver. But the making the overhead when we do the error correction, you can convert the pattern from the error to the real value, to the real data. Okay, here in this I have a box. Inside is have a circuit. The circuit, this is a parity generators. For more detail about the parity generator circuit, you can search from internet. Inside is made from the exclusive OR. It's not very hard, very difficult for making the circuit. Okay, here I have a pattern 0, 1, 1, 0, 1, 0, and 1, 1. Then inside the parity generator is generated by look at row and column in each part in row and column. So here this is data is put 1, 1, 1 to put here 1, 1, 1, 0, 1, 0 put here, and 0, 1, 1 put in this. And then consideration in the row, in each row here in the vertical line, 1, 1, 1, 1, 1, 1. I change it to the even form, so I append 1 here. 0, 1, 0. This is only 1. I change it to even form. Is I put 1 append here. 1, 1, 0. I append 0 here. Now we have in each horizontal, in each row. Now consideration in each column. For this column, this is a 1, 0, 1. This is even, convert to even form, put 0 here, and this put 1, and after that reconsideration in the row, in this 0, 1, 1 is 0. Now send it to the receivers. We have a pattern and overhead. Now after the receiver get the data, the receiver have the signal have the effects about the noise generate the error bit in the red character here. I suppose this is the error bit. In the receiver, after receive the data and have some point in error, and the receiver can convert it to do the error correction by change from the bit, checking the parity bit. So here is checked in each row and each column. In each row, in each column, in each row, look at in each row first. Here in this is check 1, 1, 1, 1. Right, this is okay. This is an even form. 0, 0, 0, 1 is not even form. We mark in this position. And here 1, 1, 0, 0 is even. And then look at in each column. 1, 0, 1, 0. Okay, right. 1, 0, 1, 1, right. No. 1, 0, 1, 1. This is a 3. This is an odd form. Mark this position. Mark here. And 1, 0, 0, 1 is even. 1, 1, 0, 0 is even. Now for marking here and marking here to check the cutting point in this position. So this position is wrong. It should change from 0 to 1 to do the correction. Okay, here this is a technique for do the error correction in the computer system. Now we talk about the ASCII code and text data. The ASCII codes I searched from the internet. I searched from internet. I found the ASCII code is generated. It is created from the IBM engineer Bob Bembers developed the single code for computer communication in 1961, and the ASCII code we found ASCII code in the text file. When you open the file.txt, inside the file.txt is the ASCII code. The ASCII code from today is that ASCII code is standard format for communication. When you transmit the data to the serial communication to the microcontroller, to the another microcontroller or device, it may be changed to the ASCII code. However, the ASCII code in the original ASCII code have only 8 bits. Its limitation only 256 characters. But today the ASCII code is changed by most of the computer in the that is displayed in the browser is use the Unicode. Unicode is have 16 bits. The 16 bits we can collect the character about 65,000 characters. I think it's all language around the world. Yet this is we call the ASCII code table. The ASCII code table and collect the 256 characters, but not only A to C, small letter and capital letter, but it have a special character and also control characters. Look in this. What is this? New character. Is it like as an empty character? And start of header. Start of header relate to control in printer. In the 1961, the computer is a dot matrix printer or printer that is a printer head. The printer head control moving the printer head by use the ASCII control to start head, to start text, end text, and live feed. This is a live feed from the papers. And today this is a special control character. Some is to control in some system, to control the modem, to control in the machine, and also controls in the terminal on display in the computers. And look at this. This is a part to build the tables. To build the tables, I show you what is the part to build the tables. You can search this from the internet. Example I show you. Search this is Norton Commander indoors. Norton Commander indoors. Here, this is a very small picture. Look at the table here. This is made from this pattern. And in this is a display on text mode, but organized writing in text mode form is look like the graphics mode, but really in this text mode. Text mode form is have 25 line and 80 characters in each line. Okay, you can change from the binary to the ASCII by using these tables. Example, I convert from capital letter A. Capital letter A is A 41H. 41H. Here in this is a 10000001. This is a will 41H. Now in this topic, we talk about the data bus in computer system. Okay, the first computer system, if you search from internet, it is a 4-bit, but we will talk about the 4-bit because 4-bit is not device in the public, in the market. And after 4 bits, most of the first step of the human use the computer is a 8-bit system. We call 8-bit microprocessors. The 8-bit microprocessor build it to the computer system, model computer system, and not only the model computer system. It's used in the computer games, and here this is a 8-bit microprocessors. The power from the 8-bit microprocessor, we know 8-bit is have only 0 to 256 levels. It can generate the games. It can generate a computer system. We can make it to control the machine, use a lot of the works. The popular microprocessor during 1970 to 1978. The name is the Motorola 6502 and Intel 800X and CSOS C70. During 1970 to 1978, this is a market. The candidation is a market is a fighting between Intel, Motorola, and CSOS to build the microprocessor and tool for supporting microprocessors. The 80X, this is when compare the power, this is over 6502 and C80, and the 6502 have running in high speed, in high clock rate, and more instruction per clock rate than the C80 and 80X. But the CPU microprocessor from Motorola is used in the home computer and game consoles. I think it's related about the writing the code. Maybe it is for easy to generate the code to do the game and have the tool for develop the game. And in these pictures, I show the diagram inside the microprocessor 6502. In this is have the address bus and the data bus. Can you find the address bus and data bus? Here, this is the address bus. Address AB0 until to the AB15, and this is a data bus. Inside the microprocessor have the module about the arithmetic logic unit, register to collect the parameter and value, accumulator related to calculation, data latch to keep the data before they can do the calculation, the clock generators. The 6508 have only 4 pins. Now here this is a diagram from Intel X00X. The X00X have a data bus here, D0 to D7, and the address bus. Look, this is difficult to look at the address bus. So in the diagram inside have arithmetic logic unit. And in this is a CXT. The CXT have a data bus here, address bus, and control bus. Inside is have arithmetic logic. Temp, this is the register for keep a short time or temporal variable before calculation. And here this is a register like as a variable names. And in the circuit, in the computer game Famicom computers, this is a circuit is have the microprocessor here, and this is a gas slot. Inside the gas slot is the memory, EEPROM memory connect to the CPU. When you turn on the computer game, it read data from the memory EEPROM from the card. So in the computer system have both the computer system that I show you all of this is the when you look at the slide from the Motorola have address, data, and control, and Intel is have address, data, and control, but different in the structure inside. And also CSOS ACXT have address, data, and control. From the concept in the computer system, we can draw the diagram right here. The computer in microprocessor connect to the device, example memory and I/O, mouse, keyboard, input switch, or anything in the three bus, in data bus, address bus, and control. For the data bus in the computer 8-bit system is have 8 level. It has 256 levels. For the computer today, we use computer in 64 bits. The 64 bits have the level about 1.8 multiplied 10 power 9. And maybe some students have a question why we build or invent the computer that is a more bit, and what is the importance from 8-bit and 128 bits. In this is related to the when you calculation in circumference or circular. Example, I have when I calculate the circumference in the by wheels here. The equation is C is 2 pi r to multiply pi and r. Here this is a calculation is circumference. This is use the same equation but have some a little bit parameter. When you calculate the circular of the orbit, but it's different in the size. The size, this is a small and this is a very large. When you calculate in the very large, you use more parameter to correct the data. This is related to the pi parameter. I build the activity 2.7 to show you the importance about the pi value. When you learn in school, the pi value we understand is 3.5 14, it is a pi value. Not exactly. The pi value, you can calculate pi value from 22 divided with 7. This is generate pi value, but not exactly like pi value. It is a changing in the maybe in the a few bit below. Here this is a generated error because the pi value related to the calculation in circle. When you calculate in the very large circle, the pi value is very long value, very long sign, floating points for calculation. So you can use the good approximation. This is a 355 divided by 113. That is generate the right value for do the calculation in pi. You can search from the internet to finding the last pi value that generate from the computer. I think it's over million position in the pi value. The next one is the address bus. The address bus is related to the location in the memory. And can you remember here? This is a Motorola. The Motorola have 16 cables in address bus. The 16 cable in address bus is related to the level about the approximation is 64K. 64K. That means the Motorola can keep or access the address about the 64,000 address in the memory. This is an address, not the data. The address like as the home address. The address like as the home address. The data bus is the path to transfer like as the bus lane like as the lane to transfer the data. But address this is a location in the memory. Okay, here this is a activity 2.8 the oscilloscope. In this activity, I show you in the laboratory to use the oscilloscope measure the signal. Okay, now I think it complete in the chapter 2. Thank you. Bye bye. สวัสดีครับ